All right, guys, here I am. I'm back. After those technical difficulties I ran into earlier this afternoon, they seem to have gone away. Also, one thing I found helpful is sometimes if you've been logged in for a long time, log back out or like log out completely and then log back in. Sometimes that helps refresh things for you and get it working. So just be mindful of that if you're having any technical issues, especially if you've been logged in for a couple hours. You might want to log out and log back in. All right, so moving on, presenting data in bar graphs. Data can also be presented using bar graphs. Okay, bar graphs. You guys are familiar with bar graphs look like. It's kind of like the dot plot, except instead of using dots, you have a bar and then a scale on the left-hand side to measure how high the bar goes up. Right? You guys get it. You know how to read this bar graph. Oranges, the bar goes up to nearly 40, indicating 40 oranges. Apples, the bar goes up to 50, indicating 50 apples, etc., etc., right? A survey asked people to pick their biggest fear from a list of spiders, snakes, public speaking, flying, and the dark. 18 people responded that spiders were their biggest fear. 12 scared of snakes, 25 of public speaking, 9 of flying, and 14 were afraid of the dark. To determine what type of data was collected, categorical or quantitative, would a bar graph or histogram be better appropriate to display this data? Now, we haven't talked about histograms. It hasn't shown a histogram on here. But a bar graph and a histogram are kind of the same thing, but one would be for your categorical data and one would be more for the quantitative data. Now, here's the reason why. Categorical data would use a bar graph because you have your categories, as you can see with the apples, oranges, blueberries. You have your categories and then the bar measuring how many of each of those categories. A histogram, you'll see momentarily when we get to one, is essentially a bar graph, but the bars are connected together and they're not based on categorical data. They're based on quantitative data, ranges of values, like ages of people, heights of people, percentage wise, whatever it is, right? But bar graphs will be used for categorical data, that's stuff that can throw into categories, and a histogram will be used for quantitative data that's more numerical. So in this question about the explorer, about the biggest fear, these are all categories, right? Categories being your fear being snakes, public speaking, flying, right? That's not numerical. That's a category. So you'd use a bar graph for that information. Data is categorical, so a bar graph would be the appropriate way to display the data. So you can see that's how they would make their bar graph. They'd have their categories listed at the bottom, the scale listed off to the left side. They went by 5, 10, 15, 20, etc. And then, of course, the bar to measure each one of those. Okay. Using only the bar graph provided, I'll let you guys kind of work this out, right? Estimate how many total people were surveyed regarding their fears. So if you want to know how many people in total there were, you would just add up the amount of each bar. So the first one looks like 18 for spiders, right? I think that's what it was. Yeah, 18 for spiders. And it looks like that from the graph. You'd add that with the 12 for snakes, the 25 for public speaking, the 10 for flying, and the 15 for the dark, or the 14 for the dark. All the numbers are up here. Basically, you'd add up those numbers, you'd get your total people that were surveyed. So you add them all up and you end up with having, 78 people surveyed. Remember not to hit next at the bottom. Hitting next at the bottom will take you to the quiz. We have to go to the top, hit the arrow. Ooh, gotta not right click it, hit the arrow, and move on to page 4 here. So now histograms, like I said, it's basically a bar graph, but it's a bar graph where the bars are connected. There's no space between the bars. Okay. All right. So data can, and this is for quantitative data that is numerical in value. Like I said, like heights, percentages, things that are numbers. All right. So bar graphs and histograms look very similar, of course, but we mentioned the difference between them. So instructions, listen to each page and then select the next button to learn more. I really would rather not. I'll let you guys work through that. Well,
to determine the interval for each bin. First, organize the data set from least to greatest. Then, group the data together to ensure the
I'm listening to the video. If you are, I don't know if you can hear it.
size of each bin so that it shows your data.
I'm gonna let you guys go through that. I'm sure it's excellent work and stuff. I want to show you these examples at least. If that video didn't or did make sense, I don't know. But yeah, example 1. A survey of 20 people is conducted, and the following table shows their heights. So we have 4 people between 60 and 63 inches high or tall. We have 6 people that are 63 to 66 inches tall, 8 people that are 66, 69, and then 2 people that are 69 to 72 inches tall. Right now, we're going to use a histogram here because this is a range of values. It's numerical values. It's not categories. So we're using a histogram rather than a bar graph. Now, is it going to show me a picture of a histogram? Because that would be fantastic. It doesn't show me a picture of a histogram here. There it goes. Okay. So on this histogram, you can see our range of values in the bottom for the heights, right? And you can see the heights from 60 to 63, right? The bar takes up that range of values because that was one of the range of values up here, right? It's not a category, but it is a range of values, 60 to 63. So our bar goes from 60 to 63. And then, of course, it goes up to 4 because there are 4 people in that range of heights. And then you see the next one, 63 to 66, goes up to 6 because there were 6 people who are the heights of 63 to 66. So you see a bar graph. The bar graph uses the number line at the bottom for its bar. It's not just labeling a category. Histogram. Did I say bar graph? It's not labeling a category like a bar graph. It's labeling a range. It's basically using a number line as part of a bar graph. But we call those histograms instead. So yeah, you can see from 66 to 69, that bar goes up to 8 because in that range of values, there were 8 people between the heights of 66 and 69. And then, of course, the last one from 69 to 72 went up to 2 for the same reason. 2 people were in that height range. So that's a histogram. That's the difference between a histogram and a bar graph. Bar graph will have the spaces between it, and it'll have the categories listed at the bottom, whereas histogram, it's all connected. There is no space between the bars, and there's no categories listed at the bottom. It's just the numbers. It's kind of like a number line, the values that they go between. So remember that even though histograms and bar graphs look similar, they're fundamentally different. Okay. So which of the following can be said for certain form of histogram? So I guess they have this picture here. More people surveyed are between 66 and 69 inches tall than in any other range. That's a true statement, right? There are more people between the range of 66 and 69 than any other part of the histogram. That's the tallest bar in the histogram. The survey is biased towards people that are 63 inches tall. I don't see how that would be true. Not enough taller people were surveyed. Well, it's not really up to determine that. I mean, these surveys are done at random. So if not enough tall people were surveyed, it's because we don't pile a bunch of tall people in a room together, right? It's just we pick some random people, we recorded their heights, and we see the results we got. It obviously would be unfair if we went to a basketball academy and recorded the heights of the people there because they'd all be very, very tall. It would also be unfair if we went to a middle school and recorded the heights of everybody because everybody would be really, really short, right? So obviously there could be bias depending on your location, but if you're just going on the street and picking some random people, your survey is going to be varied, right? Not enough taller people were surveyed. Yeah, we said that. More people are 62 inches tall than are 61 inches tall. Now, you wouldn't be able to tell that from a histogram. If you labeled all your data out one number at a time, you would be able to know if that was true or false. But the histogram, you can't tell because we know that from our histogram, there were 4 people between the height of 60 and 63. But we don't know of those 4 people how many were 60 inches, how many were 61 inches, how many were 62 inches, or how many were 63 inches. All 4 of them could have been 62 inches, or you might have had 3 of them that were 61 inches and 1 of them that was 62 inches. We don't know the specifics. All we know is that there are 4 people that heights fell between 60 and 63 inches, but we don't know anything specifically about how many people were 62 inches tall exactly, or how many people were 61 inches tall exactly. The histogram does not tell us that information. So of this information, the first one is what we can tell from the histogram. All right, page 5. And this will be the last page because page 6, I believe, is just sort of the review page before you take the quiz. So these are some practice problems for you guys to go through. We'll go through maybe a couple together, but I'll let you guys kind of handle most of it. You can check your answers, I believe, on all of these. So activity 1, question 1, recent midterm grades in a math class. So 10 students got an A, 12 students got a B, 7 students got a C, and 3 students got a D. Is this categorical or quantitative? Well, since they are given in categories as A, B, C, and D, those are categories, those are not numerical ranges, this would be categorical data. Question 2, weight range of students in class. So you notice it's a numerical range of values. A numerical range of values means that this would be quantitative because these are not categories, these are ranges of values. So that would be quantitative. And then the last one, survey of favorite genres of books. Again, we have categories here, literary fiction, romance, thriller. These are categories. Categories would be categorical data. Exactly. Remember, there are more activities. There's activity 2, activity 3, activity 4. So let's just do one maybe of each of these, and I'll let you guys kind of finish the rest of them, if there are any examples like that. So the following table shows the results of the top 5 women's 100-meter breaststroke times for the 2012 London Summer Olympics. That is a mouthful, that sentence there. Rink, 1, 2, 3, 4, 5. Heat, 4, 6, 6, 5, 4. Lane. Okay, so we have the information about the swimmer, the lane they were in, the heat they were in, and then their rank and time. So rank 1 has the fastest time, rank 2, second fastest time, etc., right? So we can see the ranks of their times. We can also see their times. Can I keep the red thing on me? I'd like to keep the red circle. Okay, it doesn't matter. All right. So what type of graph would work best? Well, you are given a lot of different information here, right? And they say a histogram has numerical data that is presented in ranges. Here we are given times, which can be arranged in intervals. It's best to decide on ranges which have round numbers, in this case 0.5, right? So that each of the points fits into completely. This way we have one person in the first range, one person in the second, one person in the third, and 2 people in the fourth. So for example, I think they'll make, no, they won't show us a histogram, but you would use a histogram here and you would say maybe 1 minute 5 seconds flat to 1 minute 5 seconds 0.5. And there'd be one person in that range for that part of the histogram because one person falls between 1 minute 5 seconds flat and 1 minute 5 seconds 0.5. Then the next range could be 1 minute 5 seconds 0.5 all the way up to 1 minute and 6 seconds, which means that this would be Rebecca Sony would be the only person in that category. Then you can go from 1 minute 6 minutes flat to 1 minute 6 minutes 0.5, and this person would fall into that range. And then the last range, you could say 1 minute 6 seconds 0.5 to 1 minute and 7 seconds flat. In that case, there'd be 2 people, because both of these people fall in that range of between 1 minute 6 seconds 0.5 and 1 minute and 7 seconds flat. You have 2 people that would fall into that range of value. So you can make a histogram like that for sure. Here again, you have information about a cherry tree and height that were found. So you've got all those numbers listed. Should the data be represented in a bar graph or histogram? Well, all we have is the heights of trees. And it's not no categories of types of trees or anything. It's just the height of all of them. So I would say it's all numerical data. So I would make a histogram for this. That's exactly what they say. And a range of values. So let me go ahead, let me make a snippet here so that I can really explain to you what this is talking about. Right? So when you want to make a histogram with all of this data, here's what you would do, right? For a histogram, I'll just kind of use it on top of the screen, right? We have to figure out a range of values for our bottom portion, right? So if I'm looking at all these numbers, I'm going to see that it seems like 60 seems to be the lowest number up there, and the highest number seems to be 90. I don't know if there's anything higher than 90, but we'll go somewhere between 60 and 90, right? So my bar graph, my histogram, I would maybe start with 60, then go to 65, then 70, then 75, 80, then 85, then 90, right? So I'll have a bar between each of these. And on that bar, we'll have 1, 2, 3, 4, etc. to see how many fit into that category. So between 60 and 65, let's see how many you can find. We got 1, 2, I think I can only find 2. It only looks like there's 2 between 60 and 65. So my bar, it's a histogram, but the bar between 60 and 65 would go to 2. Let me use a different color for this as well. Do I have a choice? Yes, I do. Right? So the bar from 60 to 65 would be only 2 because there's only 2 trees of the height between 60 and 65. Now let's do 65 to 70. So 65 to 70. So let's go through our list of numbers here and find out how many go between 65 and 70. So we got 1, we've got 2, we're going to include 70 in this, 3, I only count 3. So that bar would go up to 3. Okay, and you see how that works? So you would count how many go in that range. And you would make the bars. Now, remember, make sure you don't double count anything, which is why I've been crossing them off up here as I've been finding them. I cross them off so I make sure I don't count them twice. But let's do another one. Let's do between 70 and 75, which really would be 71 to 75. So we have 1 here, 72. Let's see. 2, 3, 4, 5, 6, 7. Looks like there's 7 between 71 and 75. So I'd have to go all the way up to 7. I'll have to make more here. 5, 6, 7, right? And make a bar that goes all the way up to 7 for that range of between 70 and 75. Right? You get the idea, right? You then count how many between 76 and 78, or sorry, 76 and 80. You need to make that bar there, right? However many people that is. You get the idea. But that's what they're talking about when they're saying you make a range of values. That's how you would make your range of values kind of down here. You kind of look at the data, figure out what values you would have to go through, and then kind of, average them out, if you will. Going by 5s here seems to make sense. You could go by 10s maybe, but maybe that's too much. So going by 5s seems pretty good. There is some flexibility. You could go by 10s if you wanted. You can go by 2s if you wanted. But going by 5s seems like a nice round number to go with. Again, you can do the same thing for activity 4, right? You can create a histogram for that. Now, they've made a histogram for you, but if you would like to try it on your own before you spoil the answer, please do so. That's going to cover it. The next part is just getting ready for the quiz, I believe. Yep, it's getting ready for the assignment. So when you're ready for the assignment, hit next at the bottom, and you are ready to take your quiz. And good luck with it. You have 3 attempts at it. If you have any questions about it, if you don't do well the first time and you want to know why, we can talk about those together. We can go over your attempt. Just message me in the discussions tab on the side, or give me a message through the inbox. Okay, anything would work. Just let me know. I'll be happy to respond to you. All right, that's going to cover it. I hope you guys can do well with this. That's the only thing you have to do for this whole week. So you're good to go. You don't have to do anything else until next week, because if you look on the website, week 1 is only that 2.1 stuff. Next week we'll do 2.2 and 2.3. So I'll have videos for those. Week 3, we'll do 2.4 and 2.5. Like I said, I'll have videos for these when those weeks come about. Okay, but for now, you're just doing week 1, which is only the 2.1, only what we've done here in that quiz. All right, I'll see you guys later.